Alright, so now here's on to the example video so you can actually understand a little bit of what I was trying to say in the last two videos. So here's an example. It's from the Chapter 7 review exercises on page 366 to 367, and we're talking 10 to 11. So we want to find, this problem is asking us, if possible, find the indicated probability. If it is not possible, explain why. So this is going to deal with everything that I've talked about in the last couple of slides. So we're talking, first thing it's saying, scores on a psychological test are not normally distributed, so it's not fitting the bell curve. With a population mean of 100 and a standard deviation of 15, a sample size of 25 is taken. We want to find the probability that the X mean of our sample mean is going to be between 94 and 103. Now, this isn't asking that the psychological scores are 94 or 103. It's asking what the mean is going to be, the probability of the mean. So this gives you a clue as to what formulas to use. So we need to know that our standard area of the sample mean, or standard error, I'm sorry, of the sample mean. So we need the X mean. Oh, sorry, I'm copying the wrong formula. We need this, we need the standard deviation over our sample size of n, and we need our z-score formula, because we're going to need this, equaling to the mean we're looking for minus our mu over our standard error. Okay, so the first thing I'm going to do is I'm going to calculate this statistic, this formula. So I have 15 over the square root of 25, which is equal to 15 over 3, over 5, which equals 3. So our standard normal error is 3. So now I need to find the z-score for both this and this. So I'm going to do the 103 first. So 103 minus our 100 is going divided by this number, which is 3. So that's a z-score of 1. And I need the z-score for the 94, which is 94 minus 3. I mean 100. I can do this. Divided by 3, equaling negative 6 over 3, or negative 2. So when we want to find the probability of this, again, we're assuming that it's not normally distributed, and the sample size of 25 is taken. That's less than 30, so we actually can't do this one. Can't do n is less than 30, and not normally distributed. I'm just going to write ND for normally distributed. But number 11 says the exact same thing. Scores on a psychological test are normally distributed with ... So our mu is still 100 and our standard deviation is still 15. So the work that I just did actually makes sense for number 11 because it is normally distributed. So we can assume that our sampling distribution is normally distributed. So this is our true mean, which is 100. And we're looking for the area between 103, which is a z-score of 1, and negative 2. So we can actually just use a reference sheet of our empirical rule to figure this out, but I'm not gonna. We know with a z-score of 1 from our chart that we have I just need to select my pen, black, thank you. This area, all of this area, is 0.8413. And the z-score of negative 2, according to our chart, is, I gotta find it, is 0.0228. So here is 0.0228. 8, and we need to subtract these to find the probability. So I just need to get to my desktop so I can get my calculator. 0.8413 minus 0.0228 gives me a probability that of 0.81, I think that's at 85. Yep, 0.185. All right. So that means that if I'm sampling a whole bunch from this population, that my sample mean has an 81% chance of being between 94 and 103. Okay, so let's move on to the next example. Using the same example, we want to find the 50th percentile of sample means. So we want to find out where our area is 50%. 50% is a z-score of 0. All right, but this is not normally distributed, so I can't do anything about this. Okay, but I can, however, do this one where they are normally distributed. Remember that I can't do this because the sample size is less than 25%. So my z, I know, is equal to 0. I know that my mu is 100. I know my sigma is 15. I know that my sigma over my square root of n is 3. What else do I know? I think I know enough to find my x bar. So we're looking for our x bar. What is the 50th percentile? So I have this formula, right? Z equals x bar minus mu over this fun equation. So I need the x bar. I know z is 0. X bar, my mu is 100. And I know this is 3. Solving for x bar means that 0 equals x bar minus 100. X bar equals 100. Now, you're probably going, wait, Gendron, why'd you go through all of that? And if you're saying that, then you're right, because I don't need to worry about that, because I already know that my mean, or my 50th percentile, is going to be 100, because this is the true. This is the true mean, and this is the sample mean. So if we hit it right on the head with a z of 0, I get an x bar of 100. Okay? The American Medical Association reported during the first hour after using cocaine, the user's risk of a heart attack increases nearly 24 times. The average age of people in the study who suffered heart attacks soon after using cocaine was only 44. That's about 17 years younger than the average heart attack patient. Of the 38 cocaine users who had heart attacks, 29 had no prior symptoms of heart disease. Assume that the standard deviation of the age of people who suffered heart attacks soon after using cocaine was 20 years, while we take a sample size of 38. So it's asking us to find the 97.5 percentile of the mean age of heart attack after using cocaine, find the 2.5th percentile of the mean age of a heart attack after using cocaine. From my chart of z-scores, I know that my 97.5th percentile has a z-score of 1.96. Okay, so let me get paint in. So I know that my z-score is 1.96. So I'm just going to use the formulas that I'd given to you previously to find my x bar again. So I want to find the 95th percentile, so this is asking me what's my x. Alright, so I know z is 1.96, and I did that by reverse looking in the chart, because I looked for this in my chart, in the meat and potatoes of the chart, and I went backwards to get the z-score. So x bar minus our mu, our mu that we're looking for is 44. So I'm going to go back to paint. So our mu is 44. our standard deviation is 20. Our standard deviation, I'm going to write it over here, is 20, and our sample size is 38. So now I need to plug in, so 1.96 x bar minus 44 over 20 divided by the square root of 38. And I'm going to plug this in the calculator and get an answer. Alright, so in order to solve for our x mean, for the mean that associates with the 97.5 percentile, I need to solve the equation for this guy. And that's going to end up being 1.96 times 3.24 plus 44. And let's plug that into the calculator. So we got 1.96 times 3.24 equals plus 44. And the sample mean for our 97th percentile of the sampling distribution is, which I just had, which was 50.35. Alright, so now I believe we want to find the 2.5th percentile, which I should call up so you can see what I'm doing with the chart. So I'm going to call up one of those charts. I have called up your Z table, T9, from the student CD. And I wanted to show you what I was talking about by looking for the area. Now, I'm looking for the 2.5th percentile. So that's telling me on the normal curve, let me show you what I'm talking about, like visually. On the normal curve, okay, because we are assuming normal, we're talking about this spot, the 2.5th percentile. But that also corresponds to this area being 0.025. So, and this is the 97.5th percentile. So this z-score was 1.96. You guessed it, this one's going to be negative 1.96, but let me show you how I figured that out just in case. So I got to scan through all these numbers to find 0.025, which I did, and it corresponds to the z-score of negative 1.906. Alright, so I know my z for this other half is negative 1.96. That is not a 9, that is a Q. Oh, bother. Negative 196 decimal. Okay, so then you would do the exact same thing that I just did with standard deviation being 20, your n equaling 38, and, oh, by the way, we assume normality because our sample size is greater than 38. Okay, that's the central limit theorem. That lets us do that. So all I would do is go 1.96 equals x bar minus 44 over the negative 3.24, which was from here, and then solve for x. So x bar equals negative 1.96 times 3.24 plus 44 again, and that is going to equal 1.96 times 3.24, and that's negative plus 44, and that gives me an x bar of 37.65. So when we're looking for the 97.5th percentile, that has a z-score of 1.96. When we're talking 2.5th percentile, we have a z-score of negative 1.96. These are kind of important. These are important numbers, so I would hang on to that. And when we talk about this a little more, I'll give you more z-scores that you should just remember. So that should be, no, that's not all the examples. I put more examples in there, didn't I? I did. There's one more example with proportion, and then hopefully we will be done with these lectures and you can get to work. Alright, so the problem at hand is, according to the National Institute for Mental Health, 12% of women are affected by a depressive disorder each year. Suppose we take 49 samples of 49 women. Answer the following. Find the probability that p hat is greater than 0.15, where p hat represents the sample proportion of women who are affected by a depressive disorder each year. So we want to find the probability that when we're sampling that our p is going to be greater than 15%. Then we're going to calculate having a p hat between 0.12 and 0.15, or between 12 and 15%. And then we're going to calculate the probability the p hat is less than 15%, and then we got to find the 5th and 95th percentiles. So I've already written down some necessary information. The only thing I didn't write down are the formulas that you need to use. So the formulas that I need to use, first of all, we know that our mean is our little p. We know that the sample proportion p hat is equal to the x mean over the n, and we need the standard error, or our standard deviation, which is our p times our 1 minus p all over n. And the square root goes over all of it. And we need our z formula, which is the p hat minus the p over the p, 1 minus p divided by n. So this is a lot of annoying arithmetic, and I'm wondering why I was writing so poorly. My pen is upside down. Oh God, this is a wonderful day, guys. This is a day. All right. So first things first, I need to find the probability that my p hat is greater than 15%. So I would use a z-score. The z is equal to my p hat minus my p, which is 12.12, over this funky formula of 0.12 times 0.88, because that's 1 minus 0.12, over our sample size of 49. So, to the calculator to make this easier. Where is it? So, 0.12 times 0.88 divided by 49. And I need to take the square root of that. So that gives me z equals 0.15 minus 0.12. Again, we're again assuming normality because we're bigger than 30. So I need my calculator. So that's 0.046. 0.046. So that's going to be 0.03 divided by 0.046. I'm doing out all the arithmetic for you. Alright, so 0.03 divided by 0.046. And that gives me a z of 0. I believe that said 65. Am I? Yep, 65. 0.652. So I calculated the z-score for you, which is 0.652, which associates with this area, and on the chart it is 0.7422. So I need to take 1 minus that. 1 minus, clear, 1 minus 0.7422, which gives me a probability that the p hat is greater than 15%, or the p hat is greater than 15% of 25.78%. The next thing that I need to calculate is between 12 and, between 12% and 15%. So we have our z-score for our 15%. Now all we need to do is calculate this area right here. I know that the 0.12 is my mean, so I'm just going to subtract 50 from this number. So this area right here is 50, leaving me with 2422 in this area. Okay, because it goes all the way up to here. This is half, so my probability that it's between, so this is 25.78%, and this is going to be 24.22%. Oh yeah, and I need to find that probability of p hat is less than 0.15. Well, we already figured that out too. That was 74.22%. Fifth and 95th percentiles, we need to figure out the z-score for that. So I'm going to pause the video and look for the approximate z-scores for both. Alright, so looking at the chart, I found that my 5th percentile is associated with my negative 1.64, and my 95th percentile is associated with my 1.64. Now again, this is just like the other z-score problems, where I have a z of negative 1.64. I need a p-hat. I know my p, and I know that this is equivalent to, I don't want to go through writing all that again. And all I would do is solve for my p-hat, and then I would do the same thing like this, solving for my p-hat, and then I get probabilities that'll happen. So hopefully these videos help, and good luck.